Hey everyone, welcome to your homework for tonight. Your homework for tonight is going over the quadratic formula and how it's used. So first of all, the quadratic formula requires that you have your equation in standard form. So if you don't have your equation written in standard form, then first thing you need to do is put it in standard form. It should look like ax squared plus bx plus c, with a squared term, a linear term, and a constant. Now, it definitely has to have a squared term. It might not have a linear term or a constant, but in which case b and c would be 0. But you want to make sure it's in that order because you need to know what is a, what is b, and what is c. So you're going to decide, looking at your equation, what is a, b, and c, and then you're going to substitute these numbers into the equation and solve using order of operations. So I'm going to show you an example, and what I asked for you to do, so this is the equation. The one in black is the one that you'll see on your CAPE reference sheet. On the right-hand side, it's showing you that when we have a fraction with the same denominator, you can split it up into two parts. So if it's easier for you to think about as negative b over 2a plus or minus the square root of b squared minus 4ac over 2a, you can. You, again, do not need to have this memorized. It is on your CAPE reference sheet. And this is one way to solve quadratics. It isn't always the easiest. For a lot of times, factoring is going to be your easiest. Completing the square might be the easiest. This is not always the easiest. But if you've forgotten how to factor, or you've forgotten how to complete the square, and you need to solve a quadratic, and you have that formula sheet, you can use this. So here is the equation that we're looking at. We're looking at 4x squared plus 12x plus 9. So here, step 1, a is 4, b is 12, c is 9. So they assigned values to a, b, and c from the equation, right? Then the next step is they plugged in for a, b, and c. So anytime I saw a b, I put 12, right? So instead of b here, I wrote 12. Instead of b here, I wrote 12. Instead of a, I wrote 4. And instead of c, I wrote 9. So you're just rewriting the whole equation, but you're using those numbers instead of a, b, and c. All right, so then in the next step, what did they do? Well, now 12 squared has gone to 144. So they calculated 12 squared equals 144. Okay, let's see what else they did. In the next step now, we have minus 144, so they multiplied 4 times 4 times 9. Now notice that negative is very important, so be really careful with your signs with this. Remember, the sign belongs to the number it is in front of, okay? So then we now have the square root of 0. Why? They subtracted 144 from 144, which equals 0. Then we now have plus or minus 0. They took the square root of 0, which is 0. And then now they have 12 divided by 8, so multiplied 2 times 4 in the denominator. And in this case, notice that our plus or minus 0 is still going to give us negative 12, right? If I add 0, it's going to be negative 12. If I subtract 0, it's going to be negative 12. So in this case, there's only one solution. And it says, looking back at the original equation, why is there only one solution? Well, the original equation is 4x squared plus 12x plus 9. And the reason there's only one solution is because this is a perfect square. This is 2x plus 3 squared. And so when we set that equal to 0, there will only be one possible solution, which is negative 3 over 2. So notice again, if you recognize, oh, hey, this is a perfect square, And then you'll know that you can factor this quite easily, and you wouldn't need to go through all these steps. So this is an example in which you can definitely use all the steps, right, to solve a quadratic, but you don't need to. All right, let's try this one. So again, they made A 2, B, the coefficient of x is just 1, and C is -3. This is an example where we have negative values, so you have to be really careful. So they substituted, so they assigned values, subbed for A, B, and C. And then in this one, they completed 1 squared, which equals 1. And then they also multiplied 4 times 2 times -3. And multiplied 4 times 2 times -3. Now notice here that they wrote this as -24, but in the next step, a minus, a negative, gives us positive. So they changed minus a minus to positive 24. And then in the next one, they added 1 plus 24, and you made it 25. Now here we go from 25 to 5, so they took the square root of 25, and then they split it into 2. And they split it into 2 because we have one situation where it's +5 and one situation where it's -5. So split to 2 equations for plus and minus. And we didn't have to do that in the other one because it was 0. Plus or minus 0 is going to be the same no matter what. And then down here, they added in the numerator, right? They added -1 plus 5 equals 4 and multiplied 2 times 2 in the denominator. Now you can totally do some multiple steps at one time. You don't have to do it each step by step like this, but you do have to be careful that you're following your order of operations. You're cleaning up one thing at a time before you try doing anything else. Now it says, looking back at the original equation, could you get this from factoring? Why or why not? So we had 2x squared plus x minus 3, right? Yeah, minus 3. When we factor with a coefficient, we would say -6. The factors of -6 that can equal positive x are 3 and -2. So I can rewrite this equation as 2x squared plus 3x minus 2x minus 3. And then I can put it in the box and do the inverse. So 2x squared plus 3x minus 2x minus 3. Here we'll take out 2x, x plus 3, and then this will be minus 1 here. So we would have 2x plus 3 and x minus 1 equals 0. Here we got 1 as an answer and -3/2. Notice we would get the same answers here. So 2x plus 3 equals 0 and x minus 1 equals 0. 2x equals -3, x equals -3/2, and x equals 1. So yes, you can factor, right? And we can factor because there are two numbers that multiply nicely to give us -6 and add to equal 1x. All right, so we tend to use the quadratic equation more for scenarios that are going to be messy, that are not as friendly. So the first two examples that you've seen are actually very friendly equations. I can do them by factoring. I can do them by completing the square. We would mostly want to use the quadratic equation when we're getting some wild answers. So this is an example in which we end up getting the square root of 200. Excuse me. 200 is not a perfect square. It looks kind of like one because it's got all the zeros, but there are no two numbers that equal exactly 200 when we multiply by itself. So the best closest number is 100. And so this person broke up the square root of 200 into the square root of 100, times the square root of 2. And then they took the square root of 100, which is 10, and multiplied it times the square root of 2. That's just to make the number smaller and a little bit friendlier looking. And so here, they're going to end up, because we can't take the square root of 2, we would get a decimal. They just ended up rewriting the equation as 2 over 14 plus or minus 10 times the square root of 2 over 14. And so in situations like this, it's okay to leave it like this. In some cases, the test might ask you to leave it like this, or they might ask you to round to the nearest hundredth in decimal. And if you were to do that, then you would put the square root in your calculator and calculate that. This is the situation where they likely would not expect you to be able to find the square root of 2 without a calculator. So to show you, we can calculate this. You can use the fraction button, which is the green alpha, and then you see it, you can see these tiny little green boxes here. Click on that, and it'll set up as fractions. So we can put 1 over 7 plus, let me go back and look really quick. It was 5 times the square root of 2 over 7. So I'm going to set up my fraction, 5. The square root button is here on x squared. So the square button and the square root button are on the same button. So second square root 2 all over 7. Same denominator, okay? Equals. So then you could estimate 1.15, right? Same thing for, excuse me, get rid of all these calendar invites. Okay, 1 divided by 7 minus, fraction it, okay, 5 times the square root of 2 all over 7. So our other answer would be negative 0.867, negative 0.87, all right? And similarly, if you were to put that equation into the calculator, you would also see that that's true in your graph. All right, so it wants you to try these two, and there's another one on the back. And so you're going to start by setting up A equals 1, B equals negative 2, C equals negative 12. And now I'm going to fill in my equation. So I'll go back up and look at my equation, and it is negative b plus or minus. So negative b. Now notice there's a negative in front of this 2. So this would be negative 2 plus or minus the square root of negative 2 squared, b squared, minus 4 times a, which is 1, times c, which is negative 12, all over 2a, or 2 times 1, right? Now, I happen to have this equation memorized, but again, you don't have to. Once you do, though, it's generally in your head. It's pretty good. And so now we're going to work through this. So minus a minus becomes a positive 2, plus or minus the square root of. Now, I'm going to kind of do this all at once, but little by little. So watch the steps here. Negative 2 squared, negative 2 times negative 2 is positive 4. Minus 4 times 1 is negative 4. Negative 4 times negative 12 is positive 36, divided by 2. Okay, so now I have 2 plus or minus the square root of 40 all over 2. This is, again, a situation where it's not going to be the prettiest answer, right? But, oh, you know what, though? I just realized I did something wrong. So let me go back. Let's erase this. This is actually negative 4. I don't know, what did I say? Negative 4 times 1 is negative 4. Negative 4 times negative 12 is positive 48. I don't know what I was thinking there. Okay, so this becomes 2 plus or minus the square root of 52 all over 2. And again, you can break this up as 2 over 2 plus or minus the square root of 52 over 2. You can break it up as 2 separate fractions if you want, but if you're calculating to the nearest decimal, you don't need to. You can just put it in the calculator as 2 plus the square root of 52 over 2. All right, let's look at this one. This one is interesting because the 7 is on this side. So I need to move it to the other side to make it 2p squared plus 8p minus 7 equals 0. So a equals 2, b equals 8, and c equals negative 7. So now you can plug negative b plus or minus the square root of b squared minus 4ac over 2a is our equation. So negative 8 plus or minus 8 squared minus 4 times 2 times negative 7 all over 2 times 2. Now I'm going to work this out. So negative 8 plus or minus the square root of 8 squared is 64 minus 4 times 2 is negative 8 times negative 7 is positive 56. Let me make sure I multiply correctly this time. Over 4. Now you get negative 8 plus or minus the square root of, that's going to be 10, carry the 1, 120, all over 4. 120 is not a perfect square. So again, this is a situation where you will end up with something that is not super neat. And you can break up 120 into 2 different numbers to make it a perfect square, or you can just estimate your decimals using your calculator. All right, so that's it. I strongly suggest you practice these carefully. And again, you don't need to memorize it. You just need to know how to use the equation. That's the most important thing. We'll spend more time looking at this together, but I wanted you to get an eye on it beforehand. Today's code word is quad. And if you can tell me the root of quad and what the root of quad means, then you can get extra credit. Happy homeworking. See you tomorrow.